Okay, so in terms of what we're going to run through, Andy's going to give us an introduction to the FarmBuild project, why the government decided to implement the FarmBuild project and what its main objectives are. I'll give you a quick overview of some of the software components and services that it delivers. And then Parham's going to take you through the GitHub repositories where most of the components are stored. And then we're going to run you through an end-to-end example. So we're going to show you how you can chain together the FarmBuild components to build a business process. We'll show a little bit of code here. If you're not a developer and code bores you or scares you, just persist. We won't be doing too much coding. We'll just go to it a few times. At the end, as I say, we'll have a chance to answer any questions that you've put in and any other questions you think of at the time. And then Andy will just take us out with some description about where FarmBuild's going and how you can get involved. So that's all I need to do for introduction. I'm going to hand over to Andy now to start us off.
Okay, thanks, Ian. Yeah, so my name's Andy McAllister. As a bit of background, I head up the FarmBuild team, but I also work in spatial information sciences within the Agricultural Research Division of this department, based up at Tatura, 2 hours north of Melbourne. I'm just going to talk briefly, just a bit of background, I guess, and where and what we're doing in this space, just to give you a bit of a starter, I guess, and we'll get into the next part of the webinar. So the FarmBuild project has been developed over the last 2 years with a focus on trying to find an alternative channel for the delivery of our science in agriculture Victoria, in a way that's an accessible way for actually developing agricultural software. So providing the tools in a manner that software developers can use. And in that sense, it's really targeted at the industry bodies and ag businesses that work with software developers. That said, it's an open source environment, so anyone who's in the development game wants to play around with it can. So over the next, our work over the next 2 years is just going to continue to extend the range of services available. You'll have a bit of a look at what is there today, but there's a program of work to extend the range of services, and I'll talk about that briefly at the end. So I just wanted to cover why FarmBuild for us in the government department. Now, we're involved over the years a lot in the development of many, I suppose you would say, endpoint applications. In a sense, these provide sort of closed systems that either require government to provide support and maintenance of these systems and the users logged into these systems, which provides us with a bit of a legacy issue, as well as an information management issue. And in a sense, they don't provide the tools for companies and the like to be able to integrate those things into their own operations. So we've sort of the way the department and industry accesses information up till now has been mainly publications, I suppose, or the ubiquitous spreadsheet tools that get picked up and butchered and carried off into other applications and the like. So this is us working on how we do this in the new world. What you're looking at here is our example. FarmWeb 2 was a demonstrator we built, which is an endpoint application. And in doing that project over the last 4 years and talking with companies, it became quite apparent that while the tools were good and the like, but they really wanted to look at how they integrate those tools into their own environment. So that prompted us to go from, say, the endpoint application that you see here through to breaking it up. And Ian and Parham are going to go into the detail of how these services operate. But essentially what you're looking at now is the FarmBuild version of FarmWeb and the services that we provided through that system, which include nutrient management and all sorts of things. Originally as an endpoint application, but now broken up into components and open source that, as you can see, external partners and other parties can access. So really trying to open up that interaction with users at that level. So FarmBuild itself, as I said before, we've got a 3-year program of work ahead, but FarmBuild is a platform that's been established within the department as a platform that's supported by the department and looks at delivering sort of agricultural science and spatial capabilities in the form of algorithms, data sets and web services. And we're going to go through some of that today and some working examples, as Ian said, and really provide an opportunity for the development of, I suppose, a new channel or a digital channel for you guys to interact with the department on accessing the science that we need. Anyway, I'm going to finish up there. I'll be back at the end. If you've got any questions, throw them in the chat window, and we'll try to answer them towards the end. Anyway, I'll pass on to Ian.
Okay, thanks, Annie. So I want to just talk for a few moments about FarmBuild and what components and services it offers and how they might fit into your software systems and your business. The diagram you see in front of you illustrates FarmBuild, and so if we work from left to right, at the left-hand side we're showing what your environment might be, an application that you might already have in the marketplace or one you're planning to build. And then in the center you can see the FarmBuild components. These are the software components, the open source software components that FarmBuild has delivered to you. They're available on GitHub now publicly, and Parham will be taking you through them in a moment. And then on the right hand side you can see some services. Down the bottom you can see the FarmBuild web services. So in addition to software components, FarmBuild provides some web services that it serves from a cloud server of its own. So you can't get access to the software of those services, but you can use this, of course, through an open and public API. And then in the middle on the right hand side you can see some examples of other third-party services that the FarmBuild components are designed to interact with, depending on what you as a business and a developer choose to implement. And so, for example, that might be external mapping services, it might be geocoding and address services, all of which can be made use of in the FarmBuild web mapping component. So if we talk just briefly through these services and components, I'll start with the services. There are two main services there for you to access. One is called the Soil Area Service. This is a service that has built behind it all of the detailed soil mapping, mainly around the irrigation areas in Victoria. And if you pass into that service the details of your farm and its paddocks, it will return to you through its API a data set that breaks down your farm and your paddocks by the types of soil that sit within those various areas and the area of each of those soil types. And so rather than you having to write all of the code to do that GIS analysis, you can simply call that soil area service and get those results back directly. The other web services that FarmBuild provides are some map services. And so there are two particular layers that are being served out. One is called the rural parcel layer, based on VicMap parcel, but simplified to work in rural areas. And the second is the detailed soil data set itself that the soil area service uses. So if you have a GIS or a web mapping interface in your application, you might choose to bring that layer down and display it. If you don't, you might choose to use the soil area service directly and not bother with all that GIS stuff. Now those services do require you to register. The registration is free and open, but we want registration there just so that DED JDR can get metrics around how much their services are being used and so on. And all of that information is available on the FarmBuild website. If we look at the components now in the center of the diagram, there are four main components that have been made available. The dairy nutrient calculator, and he briefly mentioned this. This is a software component that embeds all of the calculations necessary to do a nutrient balance calculation for your dairy farm. So you can enter all of the inputs to your farming activity, the cows themselves, of course, the fertilizer, the pasture, all of those things that you input into your business. You can record the outputs from your business, the milk primarily, and things to do with its fat ratios and so on, and it will do the calculation for you and give you a balance. How much of your input are you successfully turning into outputs that you're able to sell? Another component here is the soil sample importer. This is a utility, I guess, that allows your users or gives your users a way to match lab results where you've sent out soil samples for testing, to match those into your farm, to link each row in the lab result into a paddock, to identify what the various tests are, and so on. And Param will demonstrate that in a bit more detail later. The third one down is probably the best entry point for this, and that is the web mapping component. So this is a rapid version of OpenLayers, and it enables you to very quickly and easily implement web mapping into your application and to allow people to create and edit farms and paddocks and to pass those off to the other components. And the last repo there at the bottom is an example of how to access the web services. So it's not a software component in its own right, but it will help you learn how to call those web services, what the APIs are, what you can expect to get back, and so on. Now, of course, all of this is designed to be used in your application. So on the left-hand side, we're showing a typical application, a web browser perhaps, an application server, some code. And what we're indicating there is that you can take the FarmBuild APIs, you can embed them into your custom code, you can extend them and build interfaces for them, you can call the FarmBuild services from them, and they can all be sitting underneath the hood of your application, enhancing and extending the capabilities of your application. And the last thing I'll mention is the farm data block. We've designed and opened a data block that's in JSON format, which is what we use to persist and carry all of the data between the various web services and components. So as you create a farm in the web mapping, you can export a farm data block which embeds everything you've created in the web mapping. You can pass that off to the soil area service, and it will take that to work out where your paddocks and farms are. It will work out the soil areas. It will attach them back into the farm block and hand it back to you with the results in it. Now, if you're building an application, you'll probably want to persist that into your database and pull it out of your database. If you're building standalone tools, you may choose to simply have the user save that farm data block on their disk and load it up into the components. Okay, that's enough from me. I'm going to hand over to Para now to talk about the GitHub repository.
Thank you, Ian. So just to briefly describe the technologies that we have used in FarmBuild, we are using various technologies to deliver the FarmBuild components to you, but mainly all the source code is sitting on GitHub, apart from the web services that Ian described that are not open source, and the rest of repositories are provided as open source code. So I would quickly go through the main page of the FarmBuild in the GitHub. If you go on GitHub and search for the FarmBuild, you will get to this page. It includes all the repositories we have provided as FarmBuild components. And Ian described a couple of those, but there are more to this, and I will briefly describe some of these. There is a repository called here Farm Data. This includes all the logic we are providing around the farm data, like creating the farm data from scratch, loading an existing farm data into a web mapping component or another component on the FarmBuild that can use that. And basically some of the utilities around the farm data, like if you want to export your farm data to various formats that you can use in other applications like GeoJSON or other formats that is available. There is another repository down here. It's called FarmBuild Core. This one includes common functionalities that we have used across different components of the FarmBuild, like the validations, the collection APIs that we have used across different components, and also Google Analytics API that we use to track the API usage. So we are not expecting you guys to use these repositories as a standalone API or code in your projects, because these are used across different components that we have, and they are a base for those components. There is another one I need to mention here is the webinar repository. This includes all the source code for the example that we are going to make today, and later you can go through this repository, read the instruction in that, and have a look around that code. So I want to briefly go through one of these repositories to explain the structure of code we are providing here to you guys and the folder structure, and basically see one of those repositories in more details. I will have a look at the nutrient calculator for this. And just to briefly describe, we often use terms API and examples. And to be clear about that, each one of the repositories comes with a set of examples provided to you. But the main delivery of this FarmBuild component or other ones are the API. So that is what we expect you guys to use as third-party application developers to build applications with these APIs. And examples are provided as a way to demonstrate how you can use these APIs. And if you want, you can use those as a base for your applications or take part of the code that matches your use cases. So to describe this repository structure, if you look at this page, you can see that there is a tab menu at the top. This includes a navigation to different sections of this repository. If you go down, you can see that there is a folder structure here. This is the actual code sitting behind this repository. And further down, there is something called readme.md. This is the place you want to start with each one of our repositories. This is where you get the instruction how to use this repository, what's the purpose of this code. And it has a bunch of useful links for you to go to different sections, like if you want to download this repository or if you want to see the API documentation or examples. So I will go quickly through different sections that we saw at the top to describe the important ones. There is an issues section here. You can see this section basically includes an issue tracker for you guys. If you find if you are working with the APIs and you find a problem with one of those, or if you like a functionality that is already that is missing from the current APIs and you think that's nice to add to our APIs, you can create an issue and we can follow on that, and basically it has the whole cycle of issue tracking. There is another section called Wiki. This includes the business level documentation for you guys around this FarmBuild component. So what it means is that if you want to understand what's the purpose of this repository here, what is this code supposed to do for you as a business level documentation, you need to go to this section. To describe the structure of the project itself, there are a couple of folders here and a bunch of files. To quickly describe this, there is a source folder here. This includes all the source code behind this repository. And to use this repository in your application, there is another version of the source code provided in this folder, which is the distribution version. This is a production-ready version of the API for you guys. So if you want to use it in your application, this is all you need to include. There is another folder called docs. This includes all the technical level documentation. So as a software developer, you need to know what are the APIs available on each FarmBuild component, what are the inputs, and what are the expected outputs. So this is how you can understand that. You need to go to this folder and open a file called index.html. Also, there is a link to that API documentation provided in the README that we saw earlier at the bottom of the page. And you can get to that API documentation easily through this link as well. And the other folder is the examples. This includes all the examples that we are providing for this specific component. This is a demonstration for you to understand how to use this FarmBuild repository. There are a bunch of files at the bottom, but the only important one that you need to pay attention to is the licensing. There are two versions of that file with the same content. And if you want to know what are the licensing around the FarmBuild projects and how you can use them, and if that affects your applications, you need to have a look at this file. And just to quickly go through one of the examples we have provided, you can see for this specific component, we are also including the examples links at the README file. This is just for the convenience of using those. And we are providing two sets of examples here. One is written in AngularJS, the other is written in jQuery. And the reason for that is only to demonstrate that you can use different libraries and there is no tying to a specific library. The code is, and the look is exactly similar, by the way. I will show briefly this milk sold example. As Ian described earlier, this is a way for you to calculate the nutrient out of the milk sold. So this is a simple form you see here, and there is a result section called summary at the bottom. So if I throw in some random numbers and hit this button called calculate by percentage, what will happen? It will populate some values for me. So what's happening under the hood is that it is calling an API function with the same name, and it is getting the response, basically the nutrient calculated out of the API, and it shows the values based on different parameters. So this is very simple, and the look and feel that you have on this page may not match your application. This is not the final product, so you are welcome to change this look and feel or completely make your own. Now I will hand over to Ian to describe the flow of the work we are going to do today as the rest of this talk.
Okay, thanks. Okay, so hopefully now you have a bit of an understanding about what the FarmBuild project is intended for and some of the components that it has and where you can go to get access to the code. What we want to do now is run you through a bit of a worked example. This will take up the next 20-25 minutes and show you how you can take those individual components and put them together into something that is useful, I guess. And in this example, we're going to put together three components, or rather two components, and the same one twice. We're going to start off showing you how you can use the web mapping component to allow your user to create a farm. And then we'll export out of that the farm data block that contains that farm that we've created. And then we'll take that farm data block and we'll use the soil sample importer component and a sample lab test result file that we've prepared earlier, and we'll act as a user and match those together. And then we'll export out a new version of the farm data block which will have all of those soil test results attached to the farm data block. And so then we're going to actually extend the FarmBuild API beyond anything it does at the moment, just to show you that that's also relatively straightforward. We're going to, Parham's going to change the web mapping component so that it will actually pay attention to those test results attached to each paddock and colour up the paddocks in the map view based upon whether the level of that chemical in the soil is low, medium or high. So that's the workflow that he's going to work through. He'll demonstrate the user interface in each case. He'll go and do a little bit of a look at code, but only a relatively small amount, and also show you what the farm data block is looking like as we gradually add data to it. So I'll hand over to Parham now to start working through that example.
Okay, I'm back, and we will start doing some web mapping now. So to start our web mapping journey, we'll first need to create a farm data block. I will open the main web mapping page first. I've downloaded the code behind that webinar repository, so that's how you go to the repository. If you're a Git user, just clone the repository. If you're not, you can simply download and get it in your desktop and open the zip file. I've already done that, so I opened the file, and if you go inside that folder that you've downloaded, there is an index.html. That's the main file you need to open to get the project running. So this page, simply what it does is that to create a farm data block from scratch, which is using an API function under the hood and with the exact same name, or if you already have a farm data in a JSON file, you can use to load it into the web mapping session. So in our case, I'm interested to create the farm data from scratch. Just to have a quick look at the code behind this page, the JavaScript code, I'll show it quickly in my text editor. So this is the function actually responsible for creating the farm data from scratch. And you can see that there are many lines of comments provided here for you guys. We have tried to provide as much comment as we can so you can understand the code and what's happening around calling different functions. So what's important here, this is actual API call that is happening to create the farm data block. So, and we will pass a couple of parameters and we will get the farm data block in return. I go to the user interface again and just create my demo farm here. You can provide extra parameters, but that's something you can read on more later, going through the API docs. So this is the main web mapping page. This is the actual page that we do the web mapping and editing our polygons and things like that. On the left-hand side, I see a form, basically, that includes all the attributes of my farm. Currently, it's only the name. I haven't drawn my farm yet. A couple of buttons to export the farm data and doing various actions. On the right-hand side, I have a mapping interface that has some standard mapping controls, things like snapping. This is the measuring tool for length, area, and there is this control that gives you the capability to zoom to the extent of your farm. These are actually provided as open layers controls, and also we are providing some helper functions to optimize this. So you can enable, disable something like snapping functionality easily. There is an address search, and there is this also a layer switcher here. It includes some of the base layers and includes two specific layers called farm and paddocks. These are specific layers that web mapping knows of, and you need to provide these to be able to do the mapping of your farm. And I will show the code behind this so you can understand how is this happening and also how you can extend that. And there is a selection here whether you want to edit your farm geometry or paddock. This is necessary, but obviously you don't need to think of your user interface to be like this. You can create different approaches to target these goals and achieve, for example, this selection. It doesn't need to be a drop-down on your page. It can be in another form. I go through the code behind this page, the JavaScript one. So the second one, this is the main function responsible for creating an open layer map. So if you remember, Ian just mentioned that we are using open layers. That's the main mapping library that we have here. And for you to effectively use these APIs, you need to know a bit of open layers and understand the concept around those. And this function, all it tries to do is to try to create a customized version of the open layers map that we can interact with to create our farm and paddock. So if I go further down, you can see that there are two specific layers we are providing here, farm layers and the base layers. So base layers includes all those 4 base layers you saw earlier in my layer switcher, and farm layers includes all the paddocks and farm layers that we have in our farm. We are providing a helper namespace on our JavaScript library to help you create these layers easily. And obviously, you don't need to use this, but you need to provide the farm layers and paddock layers. So we recommend to use this as a convenient way to get that faster. And here you can see I'm creating actually an open layer map, which means that this is actually exposed through the API. So we are not trying to hide the open layers API under our API. This is done deliberately, and it is intentional because we don't want to hide open layers APIs, so you can make the most out of it. And simply we are passing those layers we have provided at the top to the layers of open layer. And for you guys to extend this, you can add a new layer as extra one, or you can use the farm layers to add to this. Basically, if you have a standard base layer of the way that open layers expect, you can use it instead for the base layers that we are providing. So you're not tied to our implementation. You can go and define any standard base layers and use that instead. So I go back to the user interface and start my mapping. The first thing I need to do is to do a quick search to find the location of the farm. I go to Techura. We try to zoom into the area a bit, and if I zoom a bit further, I want to find the rectangular shape. I need to select the layer I'm going to work with. Firstly, I need to draw my farm. You can see as soon as I selected my farm layer, there are some lines appearing on the screen. These are actually the rural parcel layer. And as soon as you get this layer, if you go back to your layer switcher, you can see another layer is added to the rural parcel. And this is using the one of the services we have under the FarmBuild, which is the WFS service for the rural parcel. So what it does for me is it helps me to draw my farm by using snapping. It makes it really easier. So I draw a polygon for the farm. It's done now. If I click my farm area, you can see it highlighted here. And now if I go back to the left side, you can see that the area is calculated as well. Then I want to draw one paddock. Same for the paddock. You can see that as soon as I click on the paddock, I can see the attributes for that paddock on the left side. There is a name by default assigned to the paddock. You can change it, obviously. And there's an area calculated for you by the API. And you can select other parameters for your paddock, like the type, the group of that paddock. These are all customizable through the API, and you can extend this to add new items to this list. So at this point, we do have our farm data block with the definitions of our farm and the paddock we draw. So if I use this API function to export my farm data block, we can have a look quickly at that. I open the farm data block. Now, you can see that I have a couple of attributes here. There is basic information about the farm data block itself, like the date it was created, the version of this farm data block. And there is basic information about the farm, like the name, the geometry of the farm. There is information about the paddocks I have, like the paddock name, also the geometry of the paddock, if they have any grouping or type assigned to them. And basically, this is the way that we save the information into our farm data block. So what I want to do next is to go through the soil sample importer example and try to match the test results I've received from my lab. If you go back to this slide, we are finished with the first part. We have created our farm, and we have our farm data block with the definitions that we need. You want to go and pass this to the soil sample importer and link the soil results we have received from our lab with the paddocks that we have on the farm. To do this, I use an example that we have as part of the soil sample importer repository, and I simply need to go through that repository. It is under the FarmBuild, and if I go down, as we saw earlier, there is a section provided in the README for me to access the example very easily. It's taking a while longer than I expected. Oh, we are there. So the first page is similar to what we saw with the web mapping. You need to load your farm data block. So this is what you need to understand really good. Farm data is the glue between different components here. So you need to pass the farm data to the next component to be able to start from where you finished with the previous one. I choose the farm data block that I prepared earlier. This includes a simple map of a farm with a couple of paddocks. It does list the paddocks that I have and the grouping on those paddocks. That's all what we get in this page. And underneath, it's using an API function to load the farm data block, and you can then go and import this for the soil sample mapping. So next page, it expects me to provide a CSV file. And I do have that CSV file already prepared. And just to quickly show you how it looks, it's a simple CSV file. That's what you actually expect to get from your laboratory results. So you can see that there are some chemical names as the header names at the top, and some rows as paddocks on my farm, and values for each soil sample results on those rows. I go back to the web page, and what I need to do is to choose that CSV file. Now it provides me with a table. So if you're lucky like me and you have a good CSV file that has that matches all your paddock names, and the chemicals that you have as your header names in the CSV file are exactly the ones that we have provided as part of the API, and they're matching, you can use the function that we have here. It's called auto linking. So I can choose the column that I want to do the auto linking based on that, do the link, and it tries to match the rows with the name of the sample paddock name. Then I need to choose the columns to match the columns on the CSV files with the columns that I want to do the sample linking based on those. I quickly do that. And obviously you can customize this list of the options that I'm selecting here. It may be different in your cases. I think I got this one. No, that doesn't matter really. As soon as I select the last option I need to map and to link here, I get the export functionality. And similar to what happened on the web mapping, if I do the export here, I get the farm data block. And this is the export API we have on the farm data to export the farm data block. If I open that now, you can see that we have the information from the previous farm data, and something like the base information, the geometry. And if I go down on the paddocks, you can see I have some extra information about the sample results for the soil. This includes all the chemicals and the values for those chemicals. So this takes us to the end of second part of our demonstration. We are finished with the linking between the sample results and the paddocks on the farm. So at this point, I have exported the farm data block. What I need to want to do at the next step is, this is the last part, I want to basically provide a functionality for myself to color my paddocks. This is not something that we currently offer on our API, so it's not provided by the web mapping API. We need to extend the API to achieve this functionality. So we need to write a bit of code, and this is, although we need to extend the API, this is going to be very easy, really. So I go back to the text editor. To do this, I've provided another JavaScript file in the webinar example that I have provided. If you look at inside the webinar example, there is this, under the map, there is this color extension JS. This includes all the code you need to have to provide this extra functionality. So let's have a look at the code behind this. This is a JavaScript file, includes a bunch of functions, and what it really tries to do is to go through the open layers map, find the polygon that represents a paddock, and then tries to map that paddock from the open layer to the paddock that we have found, which we will find on the farm data block. Then based on the paddock we find on the farm data block, we want to go back to the soil sample importer API and get the range information for that sample results, which includes the colors as well. So to show you how it looks, I have that file open here. This is called soil classification file. This includes all the sample results for different chemicals that we are providing as part of that soil sample importer. It is sitting under that repository. under the GitHub, and you can extend this to have more sample results and more range on those. So you can see for each one of the chemicals, there is a name, there is a minimum, maximum, and some default colors for each one of those ranges. So what's the color extension is trying to do? As I said, going through the web mapping, find the paddock, find that paddock on the farm data block, then by the information we get from the paddock on the farm data block, going through the soil sample importer API and get the color based on the ranges we have. So here I'm doing the color coding based on one of the chemicals, the Olsen phosphorus, and you can see the definitions are here. So after having this code, all I need to do is to add this to my main web mapping page. That was the second JavaScript file we had a look at earlier. I need to go to the list of modules I am providing for my web mapping. And as part of that, I simply add the color extension. So I will open the web mapping API another time. We need to clear this session to get the new files loaded. I choose the sample results that we have with the chemical results already linked to that. This is the second farm data block. And if I go back to my web mapping example, now I get the colors on the paddocks. And this is doing the coloring based on one of the chemicals. So if I want to change, I can go to the code, and at the place I was introducing the chemical name, I have that as a separate line here, commented that. I just uncomment that. So instead of the phosphorus, I'm not using pH of the H2O. And I need to clear the session again to load the new JavaScript file. I open that, and I now see the colors based on the new chemical. So obviously you don't need to do that at the code level. You can have some sort of control on the UI to select different chemicals and basically refresh the colors on the web mapping. And you may have actually noticed that the code that I'm showing you here is written in AngularJS, but just to quick mention, you don't need to use AngularJS to run these APIs or use it in your projects. This is a library that we have used internally and we use as part of our technology stack for web applications, but this is not something necessary or something mandatory for you guys. So as we saw earlier in the nutrient calculator, if I go back there, I quickly go through the GitHub repository again. As we saw earlier through the nutrient calculator repository, we are providing examples for both AngularJS and jQuery. And if you go through the code behind these examples, there is no Angular functions used, or there is no external dependency on Angular. So all the dependency on Angular we have with the FarmBuild components are internal. So that's not a barrier for you guys to use it. And also they are provided as functions on the under the FarmBuild namespace on the window object. So that's all you need to know. So Angular is not a barrier for you. I need to hand over to Ian. I'm finished with the demonstration now, and we'll go through some Q&A later.
Okay, thanks, Param. So just to remind you what you've seen, so Param's taking you through an end-to-end example where he's chained together different FarmBuild components. And don't forget that this first component, the web mapping component, also made use of one of the FarmBuild services, the WFS map services, to provide the rural parcels to help you draw your farm. And he's also shown you how the farm data block is used there to transfer information between those sections. And lastly, how you can relatively easily extend the API in the examples to add a piece of additional functionality that we didn't do in the first instance, in this case, colouring up the paddocks by the soil sample results that we've got. So hopefully that gives you just a little taster of how these components can be used and how they're relatively easy to chain together in that way. Okay, well look, that's the main part of our presentation. So our next section now is Q&A, and there are disappointingly few questions being asked. So if you had any questions occur to you as you have watched this, by all means put one in now and we can answer it. If you'd rather speak, then use the hand up button and I can unmute you one at a time to ask a question, and we can deal with any questions you have. If you don't have questions, that's okay. You can follow up later with questions. And after today, we will be sending out a follow-up email. Okay, we've got someone who's put a question in there from Lachlan. The FarmBuild license is derived from Apache v2. What has changed and why? Look, I can't be specific about that, not because we're hiding something, but because I can't remember exactly why it was changed. I know that at the time we did the licensing, we decided that Apache 2 was the standard license. We did have that reviewed within the department just to look at if there were any changes that needed to be made. I can reassure you there was no change made that would limit your ability to use this code, including for commercial purposes, so that is still absolutely allowed. From memory, the only changes that we made to the license were around wanting you to allow us to have some metrics around your use of those components and the registration. So that's my memory, but look, we'll certainly take that on notice anyway, and we'll do a review and we'll get back to everyone on the webinar if there was any other change other than that one I've just mentioned. But I can absolutely reassure you it is a standard Apache license from the sense of being able to use it for your own commercial purposes in your own software without restriction. Okay, any other questions? Would you be open to accepting pull requests? Asked Lachlan again. Absolutely. So I guess our view is that in the short term you'll be having a play with the code and understanding what's there, but there's no question that the intention of DED-JDR is to build a community around these open source projects and to have that community participate in improving and extending them, bringing your real world knowledge of your various business cases and your clients to the table. Anything you want to add, Andy?
I'd reinforce that. What we're trying to establish here is in a sense a community or an interaction with developers, so that we can get our science out and you guys can provide feedback and improvement to what we do. So.
And I might add, we've already had one pull request, even though there hasn't been enormous use yet, and that was one of the users in Murray Goulburn had been reviewing the soil sample importer code that Parham just demonstrated, and you may remember the example configuration file Parham showed that indicated the configuration of the various soil chemical types and the ranges and their limits, etc. And so we had a pull request there to update that file based on some more realistic ranges and values that they believed were appropriate for particular soil chemicals. So that certainly was a pull request that we have now implemented into the code. Okay, next question. Are there potential future opportunities for promotion, say a showcase of FarmBuild apps listed somewhere? Yeah.
So definitely, to follow on from that, I was going to mention this at the end. Following on from this workshop, we're looking to run a bit of a hack day in about a month's time, where we can get developers, those who've attended today and others who are interested, to come along and actually implement and play with the code, and we can potentially use some of the outputs from that as showcases. So that's one opportunity, but there'll be plenty of others.
So for that hack day, the aim is that we'll have some developers come in and team up, and they can each pick a particular thing they're interested in implementing. We'll have plenty of support around from our developers and others to help you understand the tools and get used to the code. Ideally, we'd like those teams to publish their outputs back into the FarmBuild repo as example projects that others can use. And I think it's a great idea for us to then publish those out and give people good real-world examples. You know, I think one of the things DJDR is very keen on, to put it bluntly, and if they close their ears for a moment, they're researchers. What we really want to do is get people operating commercially and in industry bodies to bring their understanding and knowledge of this area and start to show us what can be done with these components to build useful and valuable tools. So they're very keen for you guys to now pick this up and really run with it and to help everybody understand what can be achieved. Okay, well I think that's all the questions we've had, so thanks for those. As I say, there'll be a follow-up. Yeah, so Peter just asked if you have contact details. As I said, there'll be some on a slide in a moment, but also there'll be a follow-up email to you in the next day or two, just giving you links to all of the FarmBuild resources, the website, the GitHub repos, contact details, information about the Hack Day and how to register for that. Will all be coming your way, so we'll certainly do a follow-up on that. But I might just hand over to Andy to do some closing comments now.
Yeah, thanks, Ian. So hopefully you've got a bit out of today in the sense of understanding the concepts of what we're trying to provide are not endpoint applications, but the tools and components and code to provide people with the abilities to incorporate and customize, but also provide a channel through to our science, and so that we're able to post and provide soils, nutrient and water-based science outputs from our organisation out to the developer community. So in terms of what's next with this program, we've got a project running for a few years yet where we're looking to do two things. One is support existing and new users to make the most of the platform, but the second one is actually start to, once we've got this, now we've got these concepts running and some of the services and the infrastructure up, is to start to develop and implement new services and functions. And we're already starting to, we've been working with our own department and a few others on trying to prioritise what those services might be, and I'm just going to briefly touch on the few that we're working on now. So one is actually come from a lot of feedback around quality of maps, which we all know out of Google Maps and everything else. When we try to print the things, they always a bit of a disappointment. So we've actually developed a map printing service which is really focused on printing farm maps and being able to provide a good resolution on farm maps and outputs. So that's a service we'll be implementing soon, actually, that you'll be able to access. The other one is extending our dairy work and our nutrient balance work, is a dairy farm nutrient and forage benchmarking service. So that'll be what we're working on next. These are sort of will come online in the next 12 months, I guess. And that's benchmarking outputs from nutrient balances and the like against science and science results across dairy farms across Australia. So you've got an idea of where farms sit once they do their balances and once they look at how they're utilising their forage. Farm animal distribution model, and this is a common one, where people want to just be able to describe the distribution of beasts around a farm, so that you can then link them to things like grazing utilisation, nutrient distribution and the like. So there'll be a generic model and function coming out for that. Another important area is expanding soil information availability. At the moment we're sort of providing web feature services for sort of the northern irrigation areas, but we want to extend that out a bit further to broader soils information, and we're working with our soils groups on that. Another one is pedo transfer functions for plant available water. So that's about being able to provide a service or a model which means you can provide some basic metrics from a soil sample survey, which then can provide you with a plant available water estimate, which hopefully helps with things like planting crops and water and irrigation events and the like. And the last one, which we're currently working on with a few partners, is a crop water demand service to support irrigation scheduling. So again, that'll be based on a satellite-based service, but it's going to be developed in the same way that it'll be open and accessible to a range of people if they want to work on it. I'll just stop briefly. There is another question, and not too late, Lachlan. but any plans to extend to other states. So in terms of the base data, those plans are limited. So we don't have access necessarily to other state-based data, so things like soils layers and cadastre. In terms of the models and the outputs themselves, like the nutrient model, the web mapping in terms of the imagery and stuff like that, but it's certainly the science and the models that come out are extendable to other states. So wherever dairies are being grazed and pastures are being used and nutrients being generated, that stuff is applicable. So it just depends on the kinds of functions and data we're providing as to whether that becomes an outside state issue.
And the other thing I'll just briefly add to that, Andy, is that you saw the web mapping component, and although it opened up on Victoria, it was after all funded by the Victorian government, we've been very careful to make sure there's nothing in that web mapping component that limits itself to Victoria. So you can set projections that are statewide, national projections. You can, as Parham briefly showed you, go and change the base map layers that you're adding into that system so that you might be adding another state's base map layers or perhaps national base map layers. So there's nothing about it that is Victorian limiting other than the examples we have used across the various tools. So there's absolutely nothing to stop you picking those up and putting in other examples and using them in other states.
So lastly, just to touch on how to get involved, as we mentioned before, you can register, start to make use of the code and services and provide feedback either directly to us or through GitHub, through the GitHub issues page and those sorts of things. But also we're keen that if people are interested in participating in the development of new services, certainly with industry input is pretty vital for us to make sure we're targeting what's needed and how it should be developed as a service, because as always there's plenty of options there to develop that. Just to finish off, there's contacts here. My business contact, Andy McAllister, as I said, based up in Tatura. The email and phone number are there. And for a technical contact, we have our technical guru, Hayden Lewis, who works up at Tatura as well. So depending on what kind of queries you're after, you can use those 2 points as contacts. However, being school holidays, if you try and contact me next week, I might be chasing children, so don't expect an instant response next week. Anyway, I'll leave it at that. Did you want to tie up?
Okay, I'll just finish off. So look, that's all for today. Thank you very much for your participation. It was great to have you online. We really hope that you've been interested in what you've seen. There's no question that FarmBuild at the moment is a new concept and a new project. There are some good quality tools on there that we hope you'll find useful, but as Andy's outlined, there's a program of building new useful tools and components in the future. But to reinforce what Andy said, we really need industry involvement in helping to decide which tools are the right tools, in helping to test those tools and make sure that they work for you in your commercial environments. And we really want to work with you and build a team around these projects so that we can all work together and help to improve them and make them go forward. So upcoming, you'll get some details of resources in an email. The Hack Day is coming up. Please think about registering in that and coming along and having a bit of fun and helping to build some stuff and learn some stuff. And we hope this is the beginning of a great engagement to improve some of the tools and capabilities in this area. So we'll finish off now. Thanks for your attendance and hope to hear from you in the future.